Here's another projectile problem that actually has a little twist to it. It says a golf ball was hit off the tee at a velocity of 50 meters per second at an angle of 30 degrees. How high does it go? So we're looking for its maximum height. A very classic question. There's probably a 100% chance that this question will make it to the test. So its initial velocity is 50 meters per second, and the angle is 30 degrees. So might be good to draw a triangle here. That's 50. Again, that's 30. It's VIX, VIY. So VIX will be 50 cosine of 30, which is 43.3 meters per second. And VIY will be 50 sine of 30, which is 25 meters per second. So I have VIX is 43.3, VIY is 25, A negative 10. My initial height will be 0. The final height is what I'm looking for. There's a time it took to get there, and there is its velocity there. Over here I have time as well as the forward motion. Alright, well, when I look over here, I realize I know 1, 2, 3 things. Oh, no, I don't. This does not count as knowing one thing because you have to know both of them to really count that as one. So it seems like I'm missing a fact here. And that's why some students find this to be a challenging problem, because they need to remember something. When the projectile is at its highest point, at that moment right there, it only has a forward velocity. It doesn't have a vertical velocity. And so down here, that's 0. That's the key to solving this problem. You have to know that on the max height, the velocity at that moment is 0 on the vertical axis. Horizontally, it's still traveling. In this case, 43.3. Vertically, it's not traveling anywhere. So I'm looking for this initial position, or this final position. I don't know the time at all, so I need a formula without time, and that appears to be this one. VF squared equals VI squared plus 2A, in this case, we'll do delta Y. So I have 0 squared equals 25 squared minus 20 delta Y. So 0 is 625 minus 20 delta Y. 20 delta Y is 625. So the highest point is 625 divided by 20, which is 31.25 meters. So you're going to see a maximum height problem on the test. The thing to remember to bring to the problem is right here, that the velocity at that moment is 0. If you remember to bring that in, it's an easy problem to do. This is the same starting information for the golf ball, but it asks a different question. It's hit off the tee, and then it says it lands at the same height sometime later. So what I mean by that is it lands at the same height as the tee. And the question is, how far away did it land? So I've saved myself a little time here because we already know that the initial velocity was 50, and that was 30 degrees, which with our sine and cosines, we knew that the initial x velocity was 43.3, the initial y velocity was 25. A is negative 10. It starts at an initial height of 0. How far away did it land, though, is over here. That is the unknown. So we need to figure out, the secret is to figure out the time on this side, and that way I can plug it in here, and that'll help me solve for the final horizontal distance away. Well, I don't seem to have enough information. It's always about knowing 3 things over here, and I have to know both of these to count as 1. But since it landed at the same height, that means its final height is also 0, which means, of course, delta y is 0. So I need to find the time. No information about the final velocity, so this is this equation here. Delta y is 1/2 a t squared plus VIT. So 0 equals negative 5 t squared plus 25t. 5t squared is 25t. So one of the t's divides out, and now I have 5t is 25, so t is 5 seconds. So the ball was in the air for 5 seconds, and what's important is now I can put that information, not only does it solve right here, but I also get to put it right there. Horizontally, because this is all the information I ever need, this is the only equation that's important, that delta x is equal to VIX t. So delta x is equal to 43.3 times 5. And so delta x equals about 217 meters. This, by the way, is called a range problem, because by definition the range is the value of delta x when delta y is 0, and that's what we had in this case. So if you're asked for the range, you're looking for the value of delta x, and you know that delta y is 0.